Our objective for today is 8.2a, describe relationships between sets of real numbers. So let's recall what you've learned in 7th grade and 6th grade about rational numbers. You should remember the natural counting numbers, which are the numbers we count with, starting with 1, and then 2, 3, 4, and so on. These natural counting numbers we count with, they are also called whole numbers. So we're going to go ahead and write down whole numbers on the bigger circle where it's inside. The number we cannot count with is the 0, so we cannot include it where it says natural counting numbers. So where are we going to place the 0 is where it says whole numbers. Now, the numbers that we don't count with and are not considered whole numbers are what we call integers, and they are the negative numbers on your number line. What about the fractions, the decimals, and percent? They are not counting numbers, they're not whole numbers, they're not integers, but they are part of our rational numbers. But there are numbers that cannot be considered rational numbers because they won't terminate. They will keep on repeating with different numbers, such as the pi, 3.14, 15, and so on, with different numbers. Also, the square root of 2, which is going to be 1.4, and so on with different numbers, and square root of 8. So, we call them irrational numbers. But both rational numbers and irrational numbers are part of our real numbers, or real number system. Just don't forget that there are no numbers that are common between rational numbers and irrational numbers. You should understand that the set of your whole numbers, integers, rational numbers are a subset of real numbers. And using a Venn diagram, you can correctly describe the relationship between the sets of whole numbers and the whole real number system. Now let's quickly talk about square of a number. For example, we would like to take the square of a number 3. You're going to put it on a second power, or you can call it 3 squared, which means to get the value of this 3 squared, or 3 to the second power, you have to multiply the 3 by itself twice, which will equal to 9. Now let's try a square of a 4, or 4 squared, or 4 to the second power. What will be the value? Will you be able to tell the value of 5 to the second power, or 5 squared? What about a 6 squared? What about if I want to get the square root of a 9? Meaning, I want to go back to where it came from. Now let's take the square root of a 16 by putting it inside a radical sign. What was the number that we put in second power to get the 16 earlier? It was the 4. So the square root of 16 is 4. What will be the square root of 25? The square root of 36 is 6. So the answer, if you square a number, is what we call perfect squares. So can you think of other perfect squares? Okay, for example, 100. What number did you multiply? Okay, the same integer that you multiplied by itself to equal to 100. So isn't it? It's 10 times 10. Okay, that will equal to 100. Therefore, 100 is a perfect square because you multiplied the same integer by itself. Therefore, you can write down 10 to the second power. Okay, give me another perfect square. All right, what about 144? It is a perfect square because what are the two numbers we multiplied to get 144? 12. Therefore, we can write it as 12 to the second power. So if I'm given the 100 and I'm being asked to find its square root, okay, so I'm just thinking of one of the factors, okay, of the 100, which is going to be 10. Okay, now let's take the square root of 144, place it inside a radical sign. So that means, what is the square root of 144? What is that number or factor that we multiplied by itself to equal to 144? So let's go back to its square root, which is the 12. So that's the square root. Now I'm going to show you how to use the calculator when you need to find the square, or you need to find the square root of a number. Find the square root of 8. 8 is not a perfect square. Let's go back and recall the factors that we can multiply by itself and get a perfect square. The factors 2 times 2 will give you a 4. The factors 3 times 3 will give you a 9. The factors 4 times 4 will give you a 16. And so on. And as you can see, none of this is an 8. Therefore, 8 is not a perfect square. So if I find the square root of 4 here, I know it's going to be one of the equal factors here. So the square root will be 2. If I do the same with the 9, find the square root of 9. Therefore, it's one of the equal factors, which is 3. That's the square root of 9. The square root of 16 will be, of course, one of the factors here, which is 4. Okay, so how about an 8? Let's go ahead and use our calculator. Now, let's make sense out of this, okay? You know, we're looking for the square root of an 8. And we know what are the square root for 4 is 2, square root of 9 is 3. And 8 is between 4 and 9. So you'll have an idea that the square root of an 8 will be between 2 and 3. Okay, so what are we going to do is use our calculator to turn it on. Click this. And then the square root is above here. So before you can have that function, you have to click the control. Okay, so you can use that function that's just above a button. Okay, so for everything that is above a button, you have to click the control first. So if you are to use the Desmos application, you will find the radical sign for the square root right away. Or if you are to use the Calculator 84 application that you've downloaded, you have to follow what we've been doing in this kind of calculator. So you have to click first the second button, or sometimes it's the control. Okay? After clicking that, you can click now the x squared, so to have access to that square root or radical sign on the top. And then you click the number you need to find square root of, and then click enter to have the answer. So go ahead, find the square root of the following numbers: square root of 2, square root of 4, square root of 6, square root of 8, and square root of 10. Okay? And then make sense of your answers. All right? And then find out what will be the square root of 9. Is it really between the square root of 8 and 10 here? Okay, good luck on your homework, and I'll see you in class. Remember, you can always rewind this video.